guys, hello, welcome. Hopefully we are all alright and we are sheltering in place. And welcome to Thursday. I can see we've got a few people online already started on the chat, which is good to see. So today's quiz, Ohm's law, going to do some stuff on components, circuits as well. Yeah, hopefully we're all alright. Sorry we're a bit late. Yeah, like seen in the chat, I had to go to Rill this morning to get a supermarket delivery. That's the closest Morrison's that does click and collect, and that's all I could get. But yeah, hopefully we're all staying put, staying safe, doing the work that's been set, but also enjoying our Easter holiday. So let's fire up Kahoot. Let's fire up the quiz. So and then we can get going. So here we go. So yeah, like I said, you can see the code now. Give you about 5 minutes to join this. So let's put the timer up. Okay, so yeah, I'll be back in about 5 minutes, ready to start the quiz. Okay then, so 11 of us, I think it was the 12th round, but not many of us here today. Alright, 11 to go. Alright, so let's get started then, guys. Okay, so we're going to start off with the puzzle. We're going to put our SI prefixes in order. Alright, starting with the smallest, working to the biggest. Yeah, well done guys. So yeah, correctly identified micro being the smallest, times 10 to the minus 6, milli times 10 to the minus 3, kilo times 10 to the 3, mega times 10 to 6. Well done, 64% of you. So well done Parry, well done Soggy Biscuit, well done Phil, top 3. Alright, quiz time. So which of these is the correct version of Ohm's law? Well done then. So yeah, V equals IR is the correct rearrangement. None of those, the other ones are the correct arrangement for that. Okay, so what's that done to our scores? Well done Parry, well done Soggy Biscuit, still top 2. Well done Hello, biggest climber there, or Wet Flannel up 6 places. Well done. Okay, question 3 then. Okay, which of these is the correct unit of resistance? Yep, well done. It's the ohm. 10 of you got it right. 2 of you got it wrong. Watts is the unit of power. Remember that greatest rhetorical question. What's that done to our scores? Hello is now top of the pile. Parry in second. Phil in third. Soggy Biscuit in fourth. Well done to Hello with their answer streak of 3. Okay, question 4. 1 million ohms. Makes me want to go 1 million ohms is the same as which one of these? Yeah, well done. 1 million ohms, 1 mega ohms, 1 capital M, and then the symbol. This would be milliohms with a little m, so take care of this. This is micro ohms, kilo ohms. So well done to those 8 people. What's that done to our scores? Well, hello, still top of the pile. Then we got Parry, then we got Soggy Biscuit. Okay, right. Question 5. The IV graph for which component? Alright, so this is an IV graph, and for which component? Yeah, well done. That's diode. Everyone correctly identified that. If we're in the negative direction, no current flows. And then in the positive direction, very small. Once you get over a certain potential difference, they conduct really easily. Okay, right, well, that's done to our score. Hello, still top of the pile with an answer streak of 5. Well done. Smith in second now. And Peter File, well done, is up onto the top 5. All right, question 6. Which was this the IV graph of? Yeah, well done. Everyone quickly identified that as being the filament light bulb, apart from 2 people who went for the heater. What's that done to our scores? Yeah, hello, still top of the pile. Smith now has a correct answer streak of 6. Well done. And Peter Fowler is now up to 3. Okay, question 7. What's this the IV graph of? Yeah, well done. Everyone got that right. Yeah, it's either a wire at constant temperature or a fixed resistor having constant resistance. Excellent. So, scores will be the same order. Any change at the top? No. There we are. Right, on to question 8. What is the following component sensitive to? So what causes this component to change its resistance? So people I see have guessed there whether it was an LDR or a thermistor. That is an LDR, light dependent resistor. So they are sensitive to light. The more light you shine on them, the lower their resistance. Okay, what's that done? So nothing to the top 3. Well done, guys. Phil is now into 5th place. Alright, take a look at the circuit below. What is the current going through the ammeter? Through this ammeter, what is the current? Well done. 7 of you got that right. It's 0.1 amps. What you should have done is resistance is going to be voltage divided by current. Voltage divided by resistance. So we do 10 divided by 100 and you get 0.1. Excellent. Okay, what's that done to our top score? So, top 2 still the same. Parry now up to 3rd. Well done, guys. All right. In that second, a second identical resistor is added in series to this circuit. What will the current be now? So I add 2 resistors, or add a second resistor. What will the current be now? Well done. 0.05 amps. Adding a second resistor in. It's going to double the resistance, so half the current. Well done, guys. Alright, what's that done? So, Peter Fowler's now up to 3rd. And Smith now has a streak of 10. Well done. Okay, so this next one's just a bit of information. Okay, so the next 3 questions are all going to be on this circuit down here. Where it is down there. Alright, so what will the reading on A1 be? What will the reading on ammeter 1 be? Okay, yeah, well done. 7 of you got it right. 25 milliamps. In this circuit, you basically can ignore this bottom bit. So it's just working out from this resistor and this voltage. So we do 12 divided by 480, which is 0.025 or 25 milliamps. Well done, guys. All right, so what's that done? Well done, hello. Well done, Smith. Well done, Phil. Okay, so same circuit. Now we're looking at A2. What will the reading in A2 be? This is A2 down here. Real mixed bag there. So it is 0.033 amps. Because A2 is this resistor. So we ignore this middle bit of the circuit and we do 12 divided by 360 and we get 0.03 reoccurring, which is that one rounded to two significant figures. What's that done to our scores? So well done Hello, well done Smith, well done Peter File, top three now. Okay, right. What will the reading on A3 be then? So what will the reading on this ammeter up here be? So nobody got that one right. We had equal numbers going for these two, but nobody got it right. So if we look at the circuit, the reading of A3 is going to be whatever current is going through A1 and A2 added together. So you would just add the two answers we got before to get 0.058 amps. If you went for 580 milliamps, this would only be 58 milliamps, so a factor of 10 out there. Okay, so nothing done to the scores because nobody got it right. Okay, right, so again, this is just telling us that the next 4 questions are based on this circuit. So we've now got a series circuit. Okay, so what is the total resistance in this circuit? Alright, all the answers are in ohms because I couldn't put ohms on an answer. So all the answers are ohms. What's the total resistance of this circuit? Yeah, well done. All of you bar one know that in series we add the two together, so 72 plus 84 comes to 156. So yeah, well done. So our top 2 are the same, or top 3 are the same. Getting quite close at the top now. Okay, so what are the reading on the ammeters? Okay, what are the readings on our 2 ammeters? So on this ammeter and this ammeter, what will the reading be? Yeah, well done. 0.077 amps. So you do the 156 from the previous question, do 12 divided by 156, and you get 0.0, I think it's 769, but two significant figures, 0.77. Alright, so well done. Just our top 2 on here got that right. Excellent. Still tight at the top. Alright, what will the reading on voltmeter 1 be then? Voltmeter 1 is this one round this resistor. Yep, 5.54 volts. So a couple of ways you could do this. Best way is use our current reading of 0.077 amps, multiply it by 772 and you get 5.54. The other way is you could go down potential dividers route and find the ratio of these two, and that voltage will split in that ratio. But yeah, well done. What's that done to our top board? So hello, back on fire with an answer streak of 3. Smith in second place must also have an answer streak of 3. And again, it's only 400 points between those two, so that's getting pretty tight at the top. Okay, what are the reading on voltmeter 2B? Well done guys, 8 people got it right, and I just do 12 minus the answer from the previous question, and that's the one it's closest by, so 12 minus that gets you pretty damn close to that one. That's the best way of doing that question. Yep, so well done to the top, two, although the gap has widened slightly, no, about the same. Well done to Phil, now moving up. Okay, what effect would heating up this circuit have on the reading on the voltmeter? So, if I was to apply heat to this circuit, what would happen to the reading on this voltmeter? Okay, so looks like people had a bit of a guess, judging by that split. It will go down. So well done to those 3 people who got it right. So it will go down because this is a thermistor. The thermistors generally are NTC, negative temperature coefficient. And what that means is as you heat them up, their resistance goes down. The lower their resistance, the less voltage they will have across them when in parallel with another resistor. Okay, so what's that done to our scores? Well done, Smith. Smith's now top of the pile. Excellent. Finally beat Hello into second place. Soggy Biscuits up into third. There's a big gap going into the last question then. Alright, so last question. It's between Smith and Hello. Oh no, we've got 2 more questions left. Ignore me. Alright, why does the resistance of a light bulb increase with more voltage across it? Read these carefully because there's not a lot of difference between them. Yeah, well done to 5 people who got that right. The higher the voltage, the higher the current across our bulb. Higher current makes the bulb heat up, alright, making it harder for the electrons to get through. because the metal will be vibrating more, the electrons struggle to get through them. Okay, yeah, well done to Smith. Well done to Peter File. Up into third. Well done to Phil. Up into fifth. Okay, so double points for our last question. Alright, what is the current flowing through the ammeter? Double points, longer to work this out because I want you to spend the time to work it out. So we're looking at what is the current through this ammeter. Telling me I'm muted. Sorry about that. Alright, so, like I was saying, well done to Smith for being first. 20 out of 22 is excellent. Well done to the other two. Those are also pretty damn good scores on that quiz. Be back Tuesday with another physics quiz. Not sure what topic yet. It's kind of getting towards the end of electricity. But I will let you know via Twitter, via emails, what it will be on. If there are any topics you want, email me, get in contact via Twitter. Like I said, stay safe, keep following all the rules, and we will hopefully see you soon. Alright.